Welcome everyone, I'm Dave Pike from Connector Geek and I'm here today with Bill Wilson of Molex. We're going to talk about the PCIe products, the latest products from Molex. So welcome, Bill.
Hi David, thanks for having me.
No problem at all. So data is going to be one of the most important raw materials of all our lives coming in the coming years. Whether it's smartphones or the internet, data is going to be a huge part of everyone's lives, and that's driving incredible developments in things like data centers and servers. And from what I understand, the PCIe products are perfect for that kind of application. So Bill, what is the Molex NearStack PCIe products, and what kind of market needs is it there to address?
Sure, yeah. So the Molex NearStack PCIe product family is a high-speed, dense internal cable assembly and connector product family that supports and meets the transition from PCIe Gen 4 signal speeds to PCIe Gen 5 signal speed. So as the market evolves, as you mentioned, data is becoming more and more critical to get from point to point within the system and outside the system. And along with that comes higher requirements for signal integrity as well as density on your board. Everything from board real estate to thermals, everything's becoming more critical to execute as we try to push more data through these systems and out to the end customer, right? And moving from previous generations of standards like PCIe Gen 4 to PCIe Gen 5, for example, is critical and is going to be a continued evolution as we move through these things from a time frame perspective. So this is not an unexpected shift or something that we didn't see coming. So it's pretty standard evolution that happens every few years when large chip manufacturers for the server and data center markets align with PCIe standards to move to these higher speeds for better data throughput and improved signal integrity. But this kind of next generation technology can't just be limited to specific devices within the channel. You have to be able to enable this technology all the way through from point to point, right? Whether it's from the hard drives to the accelerators or back to the chip. This is where NearStack PCIe kind of meets this need and enables these next generation technologies in a denser, more compelling package than anything else that we had available today and is available in the market today.
Fantastic. I'm going to pick up on a couple of words that you used earlier in what you just said. I'm going to highlight the word signal integrity. Just Can you clarify for us, what does signal integrity mean in this application?
Yeah, so I've had to explain this to several people, including my wife, who is not technical whatsoever, but she actually, and I like to use this analogy actually, so she's a speech therapist. And so what she's doing when she's trying to get her students to communicate is you're trying to get information from point A to point B, right? And you're trying to do that without a loss of information so that from the starting point to the end point, the data that's transmitted can be interpreted as the data that's received on the back end. So she's doing that through speech therapy, helping the kids, get from what's in their mind out through their mouth or, however, to the end point, the receiving point, which is the person who they're trying to communicate. We're trying to do the same thing within a server or, a data center. If you're looking at the bigger picture, you're trying to get data from point A to point B through all these devices, through a circuit board, through connectors, through accelerators, whatever it is. And you want to get that data from point A to point B without degradation to the signal to the point where the receiving device can't understand what the data was, the ones and zeros that were transmitted from the initial device. So, kind of as I mentioned, there's multiple devices and multiple connectors or other things within this channel that can degrade that performance. So when we design a product, we have specific parameters that we focus on to ensure that when this is included in that electrical channel, that it doesn't, for better terms, mess up the signal more than is accepted in that path. It's kind of maybe a layman's term way to describe it, but ultimately that's kind of what signal integrity is from a higher level perspective.
That's perfect. I love that analogy. It makes it very clear what we're trying to do. So it's all about accuracy. It's all about making sure that what you feed into one end is what the same as what comes out the other end.
Right.
And I'm guessing because we're talking about more data and we're talking about higher data rates and higher speed, that preserving signal integrity becomes trickier at high speeds.
Correct. Yeah, as you move to those higher speeds, there's opportunity for higher noise, and you'll have to forgive me. I'm more of a mechanical guy personally, so a lot of the electrical stuff I rely on some of the other experts within our organization to kind of clearly outline some of those details. But yes, I mean, as you move to higher speeds, more data throughput. I mean, it's all about trying to get more data through the same type of pipe, I guess, or more information through the same amount of space, and you just get more chances for that data to interfere with each other and to interfere with outside influences as well.
Well, that's fantastic, because that then leads on to my next question about what are the advantages of the NearStack PCIe products? What
Sure.
is it that makes that product better at this job?
Yeah, so one of the things that's been unique about the NearStack product family overall, when we kind of innovated this several years ago, was we saw that all of these historic cables that that Molex has manufactured and that have been in the market have all utilized what's called a paddle card at either end of the cable assembly, which is a small PCB, which is printed circuit board at the end of each cable that functions as a interface for wire termination on one side and for the mating interface on the other side. But this basically requires some amount of soldering going on, manual soldering or soldering by some other means to terminate those wires to that board. And then also the board, that small board itself, has some loss characteristics to it that impact the signal integrity that we were just talking about. So what NearStack has done as an overall product family is remove that paddle card from the assembly. So we take the wire and we insert it directly into the contact structure of the cable. So we remove that PCB from the assembly and take the wire directly to the contacts and terminate that wire to the contact within the cable assembly. And that had not been done before in this space. So this allows us to have better SI performance. This allows us to be able to manufacture it more in a more automated way than had been done previously. So that provides more consistent performance and allows us to do things with the assembly that we had not done previously. So eliminates unwanted features and implications of this product. And we've seen now the market trending this way. We've seen other products start to look at this direct to contact type structure. So when you do something and then you see other companies or other areas of the market look at the same type of technology, you kind of hit on something that was obviously an unwanted feature in previous generations. So additionally, I kind of mentioned previously to the SI stuff that there's also a density play here, right? So just making something better from a signal integrity perspective doesn't mean a whole lot if you make it twice as big as the previous product, right? So we not only had this electrical goal to improve the product, but we also wanted to take a look at what else was out there in the same space and make something that was compelling from a density perspective as well. So we were able to eliminate some of the overall mated stack height for NearStack PCIe as well. So when you mate this cable to the connector on the board, that overall height is lower by several millimeters compared to where other solutions were that we had and that the market had available at the time when we released this. So that provides several benefits as well. Being able to put this under certain other components in your system allows you for better airflow over top of the connector as it goes into your thermal simulations and such, and just kind of creates a more compelling product overall. So that was one of the critical things that we executed as well with NearStack PCIe.
It's interesting you mentioned thermal as well, because that doesn't always come in when you're talking about electronics. Yeah, everybody's got to put fans in to keep things cool.
Right.
But I'm guessing that thermal management becomes a real issue when we're talking about big data centers.
Correct. Yeah, I mean, that's one of the biggest things from a data center perspective that is becoming more and more of a focus, is how do you cool not just the individual devices within the server or the servers themselves, but the entire data center, right? So that starts at a small level. You have to start kind of small and work your way out to the bigger picture, and ultimately it's a power play, it's an energy play, and an overall cost play when you think of the number of servers that you have in one of these data centers or other devices that all need to be cooled. The biggest energy usage is just the ability to keep these cool. Otherwise, they start to run very inefficiently, or you start to have failures. And so, starting at a very small level, I wouldn't say NearStack PCIe necessarily eats away at that overall energy savings on a macro level. But at a micro level, being able to keep something as low profile to the board as possible to enable more airflow through the system, and whether that's just the connector itself or whether that's being able to route the cable, low to the board and out of the way of other devices. That's where having multiple versions of the cable assembly to provide optimal routing also helps, in addition to the low profile. So those are things that we work with our customers pretty closely on in terms of an application and implementation of our product, helping them figure out the best way to route these, bend these, tape these cables into certain forms to minimize impact on the overall system airflow and interference with other items in the device.
So big solutions are often made up of lots of little solutions.
Correct,
and
right.
NearStack is helping out as being a small part in that overall solution. That's fantastic. What can you tell us about Molex's view on the market and the current move to PCIe Gen 5?
Yeah, so this is, as I kind of mentioned earlier a little bit, this is really driven by an overall market transition to move a lot of these devices, from the front end where you have your hard drives, if we're talking from a server architecture standpoint, to accelerators, to the chips, to any other device. Everything is starting to see that transition now to Gen 5 as the chip makers kind of make this a mainstream option available in their x86 chips. That is kind of the big catalyst that moves systems, devices to that next generation of PCIe protocol, right? So, and as I mentioned, it needs to be comprised of every device, and every item in that channel needs to be able to support that standard. So Gen 5 is what's coming in 2022, and that'll be, that'll start to peak over the next several years after that. You'll see, everything move into that Gen 5, and then you'll see kind of a roll off. And what we've already seen and what we already kind of anticipate is Gen 6, right? We know that that's coming as well. And we have some idea of what that'll look like in terms of, SI performance criteria. So we know that's going to be several years down the road. And so since that arrival is inevitable, we're already road mapping to those kind of requirements as they come out. So very sharply focused on Gen 5 PCIe right now with NearStack. But what we want to do is keep that next generation of requirements in mind as well, and work with our customers to show and enable potential Gen 6 performance with the existing product without a major design change or anything that they would have to do from an implementation standpoint that would change significantly. So we already have those kind of wheels in motion, and we're already having those discussions with customers to be able to hopefully provide like a backwards compatible solution for Gen 6 that where there aren't major revisions needed on the existing product to enable that and to support that.
Well, that's interesting. You talked about Gen 5 and then Gen 6. So just as a kind of a side question, what will Gen 6 look like? We're already, Gen 5 is what, 56 gigabits a second, PAM4? What's Gen 6 going to look like?
Yeah, so Gen 5 is actually 32 NRZ. 32 gig NRZ, and Gen 6 is going to be 64 gig PAM4. So PCIe is kind of doubled in its frequency as you look back on the generation. So Gen 5 is 32 gig, Gen 4 was 16 gig, Gen 3 was 8 gig, and so on backwards. So the big change between Gen 5 and Gen 6 is just moving from an NRZ to a PAM4 type of modulation. And again, I'm not the expert on this, but the idea is that the signal needs to get cleaner. You need to be able to provide a solution that has less crosstalk, moving from a Gen 5 to a Gen 6. But a lot of this isn't necessarily hard and fast rules yet. As I mentioned, Gen 5 is kind of just released kind of this year, next year as a mainstream option. So, one of the things that I think our customers are trying to keep up with, and that maybe the chip manufacturers are starting to catch on to, is that there needs to be some amount of saturation before you introduce a new round of generation already. Otherwise, everybody's just trying to keep up, and the device life cycles are short, and the investment in all of this technology is too short-lived to get any type of return. So there's debate on how quickly Gen 6 will be enabled. Honestly, we're hoping that Gen 5 sticks around for a while because we have a really compelling product for Gen 5, but we are prepared to support Gen 6, obviously, with mainstream solutions, not just NearStack, but other stuff across our product portfolio as well.
That's really interesting. I think the a conversation about the difference between NRZ and PAM4, that's something we could almost address as a separate conversation.
Yeah, correct.
That's going to be interesting to people, because that's all about the techniques to be able to get more data down these systems.
Right.
So that's something for another time. And I was going to ask about how Molex is looking forward to Gen 6 on the basis that it will come eventually.
Right.
But coming back to the NearStack product as it exists now, is it a market product? Is it available now? Can we get hold of it? And is there a roadmap for the next few months?
Sure. Yeah. So NearStack PCIe is a general market product. We do have part numbers on our website, samples available to customers for tests as of right now. There's 3 different versions of the cable assembly. All are in the by 8 pin out. So that's a 72 pin solution from NearStack PCIe. So there's 3 different cable versions available. One is, and it's all cable exit geometry. So the right angle cable basically exits horizontal to the PCB. We have an angle exit version, which is relatively unique, where the cable is kind of preformed to exit the cable housing at an angle so that you can then put this closer to neighboring devices without the cable exiting at a very low profile off the board and running into something that's next to it. So this angle exit allows you to kind of preform that cable over top of a nearby device. And then we have a vertical exit or straight exit cable that plugs in vertically and exits perpendicular to the board axis. And all of those are currently tooled and are available. All have the same SI performance, so there's no degradation or factors that need to be included with those different cable assemblies as you think about system implementation. But what that allows us to do is I think I mentioned a little bit earlier, be able to use NearStack PCIe in various locations in the system where a right angle doesn't make sense, but you need a vertical cable. So we've been able to tool up and innovate those different versions to support different customer applications and needs. So all of those are available today. We have test data. We have like I mentioned, samples, and then in terms of a 6 to 8 month roadmap, really what we're doing is we're in the process of ramping our capacity to be able to anticipate what the market demand is going to be starting next year. So that's our major focus right now, is kind of moving from the initial product introduction stage into the full volume manufacturing stage of the product. So kind of just moving along the product maturity timeline there. The other thing that I should mention is we actually do have quite a bit of capability in terms of turning a simple Molex PCIe to PCIe jumper cable into a NearStack PCIe to another type of product. So we are able to trim that cable in half and take those twin-ax ends and terminate that hypothetically to another solution that is maybe a little bit more customized. But we see this a lot when customers need to take their Gen 4 devices, or legacy devices within their system that don't have NearStack PCIe in them or on them as of yet, since this is a new product. But they need to be able to make those backwards compatible to their existing or their new generation system. So we can create that compatibility and cross communication through a hybrid cable that we would be able to work with customers to kind of develop alongside them. So we've already been doing that and have a lot of experience doing that as of today.
I was going to ask about that to see if what the possibilities would be for customers to come along and say, well, this is a perfect solution, but it's not quite right. Can we work with you to make it just that little bit different to fit with our application?
Right. Yeah, usually that's done through kind of what I mentioned in terms of a hybrid cable assembly. We want to obviously keep the NearStack itself as standard as possible, just because that's what our high volume manufacturing design and automation structure is around. So tweaking it typically ends up becoming something maybe custom on the other side of the cable. So like I mentioned, other products that are available out there today that are standards or that are utilized historically on legacy products, we can modify the pin out or how the wires are attached to make it compatible with other devices or applications that customers may have.
That makes it a supremely flexible kind of solution. I'm really interested in the idea of that angled version you mentioned earlier, with the idea that it allows you to maximize the space.
Correct, right.
While still fitting it into a small area. And I guess that, again, it goes back to that thermal management question we asked earlier, about how it's optimizing the mechanical, the electronic, and the thermal all in one.
Right. Okay. And we do have a YouTube video currently on our Molex YouTube site that shows all the different versions of NearStack PCIe and potential system applications, and kind of breaks out the internals a little bit of the solution as well. So it was something that we worked on internally, and I think turned out really well to kind of give our customers a good understanding of what NearStack PCIe is and what's available today.
That's fantastic. It seems to me it's a really interesting product, because obviously we've got this situation where data is going to be so much more important to everybody around the world. Looking at the Molex website, from my point of view, I always see the slogan that you've got, creating connections for life. To me, this is a product that is making life easier for people who want to consume data wherever they happen to be.
Yeah, it's always interesting. Kind of people ask me what I do and what type of products we make, and it's hard to sometimes it's hard to verbalize that, because it's all stuff that's going on behind the scenes, right? So, when you access your email is stored on a server somewhere in a data center, and ultimately our products are enabling you to access from your cell phone, access that email located on some server's hard drive hundreds or thousands of miles away. But people don't see that, right? People don't see what's happening inside the system. People don't see all the technology that it takes to enable that email app to open and for you to access that attachment that's on a new email that you just received. But that's what we do. I mean, we enable people's lives to connect, and whether that's connecting to each other or connecting to information. In NearStack PCIe, we expect that to be a big part of that over the next several years as this evolution takes place in the server and data center arenas.
No, that's fantastic. I think it's very easy for us to forget the amount of hardware behind the scenes that goes into making sure that we can stream our videos and receive our emails and take our phone calls. So it's fascinating to look at what the technology looks like in terms of enabling this information revolution, for want of a better way of putting it.
Correct. Yeah.
Yeah, with with things like 5G coming along, I guess this type of application is just going to become that much more prevalent, with the amount of data that's going to be shared between different people and different devices.
Yeah, I couldn't have said it better. I mean, you're having all of these new technologies kind of all working together to enable this connected infrastructure between people and devices and vehicles and everything as we move towards a more data-centric experience across the board.
Fantastic. I want to summarize. I want to say thank you so much, Bill, for giving us an insight into the NearStack PCIe product from Molex. It is fascinating to see the hardware behind the scenes, as I say, and how our information is being provided. The cloud is something that people talk about all the time, but the cloud is actually a physical location with lots of equipment that's doing a very complex job. So from that point of view, it's been absolutely fascinating to talk to you about this type of product, and the fact that it's going to play such a big part in our lives, whether or not we know it or not.
Right. Fantastic. Yeah. Thanks for having me. It's been a great conversation topic, and check out the Molex website as well as that YouTube video, and there's more information there. And let us know if you have any other questions.
That's brilliant, Bill. Thank you so much. Thank you to everybody for listening, and we'll see you soon.